All right, so this is an ALEKS topic that's called Interconverting Compound SI Units. And this is basically just a unit conversion dimensional analysis type problem. So looking at this, basically what it's asking us to do is it's giving us this value, this number, with units of grams times centimeters squared over seconds squared. It wants us to convert to a different set of units, to kilograms times meters squared over seconds squared. So I guess the way that I would sort of systematically go about these problems is I would sort of look at, the different types of units that I have and figure out which conversions I'm going to need to do. So when I look at this, basically I can see I need to convert grams into kilograms. So grams here to kilograms here, and centimeters squared into meters squared. The next thing I'm going to want to do is figure out what the conversions are between these different, units. So I know that 1 kilogram equals 1,000 grams. I always like to put the sort of bigger term as a 1 and then have, 1,000 or 10,000 or whatever, 100, 10, whatever, the smaller unit is. I think looking at it this way just makes more sense to me, and I would encourage you to do the same thing. Now for centimeters squared to meters squared, I know that meters will be bigger, so I'm going to say 1 meter squared, and then I'm going to try to figure out how many centimeters squared 1 meter squared is. So 1 meter squared is actually 10,000 centimeters squared. And the way that I figured that out, the way that I know that, is that I know that 1 meter squared is 100 centimeters times 100 centimeters. So that's going to give me units of 10,000 centimeters squared. So that's the conversion that I'm going to need to do. Okay, so now I'm ready essentially to use these conversion factors to do this conversion. So I'm going to start over here by writing grams times centimeters squared over seconds squared. And then I'm just doing a unit conversion. I'm using these relationships as unit conversions times 1 kilogram over 1,000 grams. And I can see that my units of grams will cancel out and I'll get units of kilograms on the top. Same thing for centimeters squared. 1 meter squared on the top, 10,000 centimeters squared on the bottom. My units of centimeters squared will cancel out, and I'll get a value, or I'll get a unit of kilograms times meters squared over seconds squared, which is the unit that I'm looking for. And then the last part here is just actually plugging the value in, 2.76 times 10 to the 8th. That has these units here. If I do these conversions, divide by 1,000, divide by 10,000, I should end up with a value of 27.6 kilograms times meters squared over seconds squared. I've got another example for you. So we'll go through the same exact process for this second example. I see that we've got kilograms and grams, so I want to convert kilograms to grams. Again, we'll think about what that conversion is going to be. 1 kilogram should equal 1,000 grams. Next, I see deciliters and liters. So this one I actually just looked up on Google. I wasn't sure. I thought it was 10 to 1, but I wasn't 100% sure. But in fact, it is 10 to 1. So 1 liter will equal 10 deciliters. And again, if you're not sure about these, right, just look them up, right? You can see what the conversion that has to happen is, deciliters to liters. So just Google it and see what that actual conversion is. I think kilograms to grams, right, that should be one we know. Milliliters to liters, that should be one that we know. But something like this, I would just look it up real quick. Now I'm going to use that same sort of philosophy when I do my conversion that I did last time. 5.6 times 10 to the minus 6 kilograms over moles times deciliters. I'm going to now just do this dimensional analysis, this conversion, 1,000 grams over 1 kilograms. I can see that my units of kilograms will cancel out, leaving me units of grams on the top, which is great. Do the same thing for the deciliters. 10 deciliters over 1 liter, units of deciliters will cancel out. That will give me a value of 0.056, and then units of grams over moles times liters, which is the units that I'm shooting for. So then this would be my final answer here that I would plug in. All right, hopefully that helps. Let me know if you have any other questions.